find each missing factor. Blank times 7 is equal to 63. So you should have learned your times tables by now, because you need to know up to 12 times 12, like 1 times 12, 2 times 12, 3 times 12, all of that up until 12 until you get to 12 times 12. So just calculating it, you should be able to get 9 times 7 equals 63. If you can't do that, just like do 63 blocks maybe and group them, and then make groups of 7 and see how many groups you can make. It's a definitely more time staking process, so I'd 100% recommend just memorizing it. Like, you will be getting it eventually, and I think it's better done sooner. It'll make your life a lot easier. Then blank times 5 equals 50. Using the base 10 like property, you can just do this, because like any number with like a 0 at the end is just the first number multiplied by how many zeros there are. So it's 5 times 1 0, which is in 10, because there's only 1 0 in 10. And then 10 times blank equals 100. So like, let's say you have 100 here and then you have 10 here. It's similar like this, so you only need this 1 0. So then 10 times 10 is equal to 100. 8 times 9 is equal to 72, because 8 plus 8 plus 8 plus 8 plus 8 going on to 9 times is 72. And then moving on, 9 times blank is equal to 54. 9 times 6 is equal to 54. You can calculate this if you want. 9 plus 9 plus 9 plus 9 plus 9 plus 9. I'm not entirely sure what the difference between this and just thinking of the answer in your head would be, because you would have to like kind of calculate this, but it's okay. So like, you could use this method by doing like blank times 4 equals 40. So you could do 4 plus 4 plus 4 until you get to 40, and then count how many 4s you needed. So in this case it would be 10, using the same reasoning as questions 2 and 4. Then moving on, write each rule for each table, then complete the table. So just completing the table, you can see that it goes up by 8 every time. So 32 plus 8 is equal to 40. 40 plus 8 is equal to 48. So the rule for this is, for every one spider, there are 8 legs. So basically, spiders times 8. And then moving on, toy cars. So 2, 4, 6, 8, 10, 12. And then for every one car, it costs $2. Guitars. So 12, 24, 36, 48, 60, 72. If it's hard for you to just count in your head, you can also just add to like this. So 8 plus 2 is 6. 8 plus 2 is 10. Carry the 1, 6. You get 60, and then you keep doing that until you get to 72. Every one guitar, there are 12 strings. Okay, and then moving on. So find the product and explain if you used identity property, zero property, commutative property, and associative property. So find the product. The answer to this is 0, and we use the 0 property for this because we know that any number times 0 is just equal to 0, because you can't multiply a number by nothing and get greater than nothing. So this is 0 property, and then 1 times 7 is equal to 7, and this is identity property, because any number multiplied by 1, because there's only one of that number, is automatically that number. So like 1 7 would only be 7, and 1 3 and would only be 3, 1 4 would only be 4, and like you keep going with that. And then 3 times 2 times 7, this would be 14 times 6 times 7, which is 42. We used associative property for this, because it doesn't matter the way you group this, and it's a lot harder to do 14 times 3 than it is to do 6 times 7 in your head. So we can just change the groupings, because when you're multiplying just straight in a row, like multiply, 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 the answer just stays the same no matter what order the numbers are in or how you group them. And then moving on to the next question, 7 times 7 is equal to 49. For this, we use the commutative property, because if you change the order of this, it's still 7 times 7, and it doesn't really matter. It's basically the same thing as associative, but associative is grouping, and commutative is just like changing the order that the numbers go in. So yeah, and then 6 times 9 is equal to 54. This could also be commutative property because you can just change the order of the numbers. So like 9 times 6, 6 times 9, whatever's easier for you. It doesn't really matter. Lily has one basket with 9 apples in it. How many apples does she have in total? So one basket with 9 apples. With 9 apples. So how many apples does she have in total? She has only one basket, and that one basket has 9 apples. So she has 9 apples because just 1 times 9. Noah has 5 empty trays, each with 0 cookies. How many cookies are there in total? So he has no cookies on any of his trays. So 5 times 0, using the 0 property, you get 0. Because it's just empty trays, because he doesn't have any cookies. Emma has 3 bags, each with 4 marbles. How many marbles does she have if she counts 4 marbles in each of her 3 bags? So if she has 3 bags of 4 marbles each, it's basically 3 times 4, because 3 groups of 4. So she has 1, 2, 3 groups of 1, 2, 3, 4. No, 4, not 5, 4. So then basically it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12, because 3 times 4 is equal to 12. I kind of did this confusing. This is an example of commutative property, because you could honestly switch these numbers around and it wouldn't make much of a difference. It wouldn't make any difference, not much of a difference. So James has 2 groups of 3 toy cars, and each car has 5 stickers. How many stickers are there in total? So he has 2 groups of 3 toy cars. So first of all, that's 6 cars, because he has 1, 2 groups of 1, 2, 3, 4, 5, 6 cars. Each car has 5 stickers. If he has 6 cars and 5 stickers on each car, that's 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Just count by 5s, 5, 10, 15, 20, 25, 30. 6 times 5 is equal to